Hello everyone and welcome to PC Retro Tech. So in this week's video I'm going to be trying to answer a burning question that I've had for a number of weeks now, ever since I realized that I've been really lucky to acquire a number of working 20 megabyte hard drives. Now of course it's really hard to get drives from this era that are actually in working condition, and so I've been lucky to accumulate quite a number of different kinds of drive. So the question is, if I put these in the same machine under the same test conditions, how does the performance compare? Now it's an interesting question because you wouldn't expect all of these drives to be in the same machine or even in machines of the same era. So let me just run quickly through what the drives are and I'll explain. So the one in the middle here is a Plus Development HardCard 20, and you might recognize this from my video on repairing it. So I bought this drive in brand new condition, unopened, sealed, in original packaging. But I realized that these drives contain a rubber stop in the middle which prevents the heads from banging, and unfortunately it turns to goo over time and it actually prevents the heads from moving. So this had to be repaired, and I basically got it going. It's still a little flaky actually. The hard drive surface itself is not in great condition, so that may affect the results here today, but I have noticed that once it warms up it seems to work flawlessly, so we'll do that today in our attempt to get some kind of meaningful result. So that kind of drive was really intended for a machine like an IBM PC where you might not have space or power for a hard drive. So in particular, the IBM PC had a very low wattage power supply, and if you put an ordinary full height drive in, it would just burn out the power supply. So it also would be suitable for some kind of PC clone where you might just not have space to install a hard drive, and so the idea was to have the controller card itself and the hard drive all on the same full-length card. So the next two would probably be more likely to be found in a machine like this, a 286. These are MFM drives, and at the back you have the Western Digital 262. This is obviously a 3.5 inch half-height drive, but it's currently in a 5.25 inch bay, so it would be similar to what's in there. And that's also a 20 megabyte MFM drive. So this one here is a Seagate, it's actually a 251, but in the machine itself I have a Seagate 225, and the 225 is 20 megabytes. The drives look identical, so this is what it actually looks like without the faceplate when the drive is taken out of the machine. So that's obviously a 5.25 inch form factor. And I found both Western Digital and Seagate's to be quite reliable from this era. I don't have quite as many problems with faulty ones, although of course they still exist. Now the other one is quite rare. This is a Connor CP3024, and you might want to look this one up. This is actually a 20 megabyte IDE hard drive. And yes, they really did make a 20 megabyte IDE drive. So of course I'm going to have to change the controller out. This has got an MFM controller in it at the moment, but I have one of those that I can substitute and it should run in this 286. So at some point I realized that I am able to run all of these in the same machine, and it'll be very interesting to get some software and compare the performance. So for checking the performance of the drives, I'm going to be using this system information tool which comes with the Phil's Computer Lab benchmarking suite. So I apologize for the flicker here. Of course it's unavoidable, and it's to do with the sync rate of the multi-sync monitor that I'm using here. But this particular drive is the Seagate ST225, and it's giving it an overall score of 1.3, which is very low, as you can see, even compared to an ST251, which surprised me a bit. So the average seek time is 87.74 milliseconds, track-to-track seek is 20.3, but I think the most interesting result here for us is probably the data transfer rate, which is 150.3 kilobytes per second. So here are the results for the Western Digital 262, and as you can see, it's giving it a score of 1.1, which is actually slower than the ST225. So the data transfer rate here is only 135.1 kilobytes per second, so it's significantly less. And the seek times are also quite a bit higher, about 50% higher in fact. So this seems to be a slower drive, even though it's a 3.5-inch form factor MFM drive, which you would imagine would be comparable to the ST225. But that's why we did the benchmark, to find out these things. So let's move on to the next drive. So as a bonus, I decided to actually just benchmark this Seagate ST251-1, since I actually have one, and this system information program tells me that I should be getting a score of 2.3 for that, and indeed I actually get a score of 2.4, so that is in fact consistent. And the remarkable thing about this is that the average seek time is only 28.83 milliseconds, which is incredibly low. And the track-to-track seek is even more amazing, 7.66 milliseconds, which is, almost a third of the track-to-track seek of the next best one that we had, which was the ST225. The data transfer rate is not that much higher. It's only 165.6, so it's only about 10% better than the ST225. So I guess that the score, the aggregate score here of 2.4, is really coming from all three of those figures. And I can speculate that maybe they just improved the hardware and the stepper motor is just able to move much quicker between the tracks. The other possibility, of course, is that the tracks are just much closer together, but I think that doesn't make sense here because the numbers here are so much lower. I think there really has to have been some kind of hardware improvement as well, rather than just having to move half the distance between the tracks. In any case, that was a really interesting benchmark, but do bear in mind that this is a 40 megabyte drive and isn't really included in the comparison that we want to do today. So let's move on with that, and we'll try out the HardCard next. So although the HardCard does actually work with this system information tool, it doesn't actually complete the benchmark, and I'm not sure whether that's because there's some problems with the seek test on this drive, or whether it's just not compatible with this drive. You can hear it at the start of the benchmark doing what sounds like moving some files about, but then it just hangs and nothing happens after that point. I've left it for some minutes and there's just no change. So I'm going to go and look and see whether I can find a different program that we can run to get some data for this drive. So this is the benchmark for the Connor CP3024 IDE hard drive, and you can see that it's given a very, very high result here. The data transfer rate is actually 505.3 kilobytes per second. The track-to-track seek is 4.65 milliseconds, so this is really a lot faster than the other drives that we've looked at so far. Now, it took a long time to actually get this far because it's really quite difficult to get this drive working as well as a floppy drive in this machine. So in fact I wasn't really successful with that. I can boot from a floppy disk, but then shortly afterwards the floppy drive becomes inaccessible. I can still access the hard drive, but I can't boot from the hard drive. So there's no way for me to copy the benchmarking tool, or even to run the benchmarking tool from a floppy. So what I had to do here is put the benchmarking tool on the Plus hard card, boot up on the Plus hard card, and then run the benchmarking tool from there, but choose the IDE drive as the one to benchmark. So that actually worked, and it's quite funny because, of course, the Plus hard card doesn't work with this benchmarking tool. It'll start up, but it simply hangs when it tries to benchmark the Plus hard card. So anyway, it looks like the IDE drive is by far the fastest drive so far. So now we're going to go back and try to find a way to benchmark the Plus HardCard. So I finally found a program that will actually work with this Plus HardCard. It's called the Core Disk Performance Test Program, and this one actually gives reasonable values for this drive. It does vary a bit when you run the program more than once, but it's reporting 159.1 kilobytes per second, and the track-to-track seek is 9.1 milliseconds. So this is really quite a fast drive. It's just that it was difficult to find a program that would actually work with it. So I'm going to go and use this program now on each of the other drives so that we've got consistent data to use for all of the drives, and then I'll give some graphs of the relative performance. So these are the figures that we get with the Core Disk Performance Test Program using the Connor IDE drive, and the results are actually quite similar to those that we were getting with the sysinfo tool, but I'll go through the other drives anyway, just so that we've got a consistent set of data. So here are the results for the 40 megabyte ST251. So this was the drive that we found was a little bit faster, but the one that we're not really benchmarking today. And so this gives 163.2 kilobytes per second and a track-to-track seek of 12.7. So that's still pretty good. So I'll move on to the other drives. So this is the Western Digital drive. I actually was getting a lot of seek test failures on this, and the test wasn't completing, but I seem to have it working this time around. So the transfer rate is 158.4, and you can see that track-to-track seek at 18.8, which is quite a bit better than what we were seeing before. So I don't know whether that's a problem with the hardware or the software. I certainly wasn't getting seek errors with the other software, so I'm beginning to suspect that the software itself is not particularly compatible, or maybe it just tries to drive this hard drive too fast. At any rate, the other value of 158.4 is obviously well in advance of what we were getting with the other software. And finally we have the scores for the Seagate ST225, and the values are a little bit higher here than they were before. For example, the data transfer is 160 instead of 150, and the seek times are around about the same. The average seek times are a little bit lower here in this test, and basically I think that this program just drives the hard drives a little bit harder than the other program. It's also possible that that Western Digital drive had an interleave that wasn't really suitable for that particular drive. So here we have a summary of all the results, and you can see the thing that stands out immediately is that IDE hard drive with transfer rate of 531 kilobytes per second, which really just completely outstrips all of the other drives in the lineup. So I put all 5 drives here, including that 40 meg drive, and you can see that the 40 meg drive had significantly better seek times than the other MFM drives. So obviously technology had moved on quite a bit by the time they were making those. But even the seek times on the IDE drive are really incredible compared to the others. The Plus HardCard did have slightly better seek times, but its transfer rate was exactly the same as all the other drives except for the IDE. And so I think that's the conclusion here. If you can get hold of a very small IDE drive, a 20 megabyte one, good luck doing that. They're really rare. But if you can get one, that will perform extremely well. They do work in the machines. I actually thought that I was having problems with the floppy drive working at the same time as the IDE drive, but it turns out that the floppy drive was just chewing through disks, and I'm not sure why that is. I don't know whether there was some kind of software problem here, whether maybe one of these hard drive tools was actually corrupting the floppy disks, or whether there's a virus, or whether there's a physical problem with the floppy drive. I really don't know, but I noticed in the end that if I put the files on a fresh floppy disk and write protect the disk, I was able to get it to work again, and so it just seems that it was killing disks at some point. Anyway, so the conclusion seems to be IDE first, plus HardCard second, other MFM drives third, although obviously if you can get a later MFM drive, it's probably going to perform much better, at least as far as seek times. So I hope you've enjoyed this look back at the early history of PC hard drives. If you like this content, then don't forget to like and subscribe. And that's it for today. Thanks for watching, and we'll see you in a later video. Bye.